As you may know, I'm from Russia. And here in Russia, discussion about electric vehicle often comes to the conclusion that electric vehicles are good, electric vehicles are nice, but they are not so suitable for cold weather. First, I was not thinking much about that, because you see, due to a simple reason. Nowadays, market share of electric vehicles are still rather low, and major car manufacturer can afford themselves focus on the markets with mild or warm climate. And there are not so much reason, or there were not so much reason to spend the money and what is more important in present days, the precious time for developing a battery system focused on work in cold region. But later I have realized that this comparison of electric car and gasoline car during winter is important first in order to help switch our mind of old style thinking. And also it's just an interesting, funny maybe example of why electric vehicles are not so bad and even are so good in different conditions. So let's talk about electric vehicles and gasoline car comparison at cold weather. You see, when we're talking about vehicles and driving during the winter, we have to keep in mind that you need the source of heat. And by the way, when we're talking about cold weather, I mean cold in Russian understanding. It means from -10 to -30 or even -40 degrees centigrade, or from 0 to -40 degrees Fahrenheit. So when strong colds are anticipated, Russian local emergency service where drivers avoid driving transportation between cities, or at least to check the fuel level, check engine, check the battery before such a trip, before road. Why? If your car will broke down between two cities when you're far away from the city, you will need the source of heat. When we talk about electric vehicles, the source of energy transferred into the heat is the battery, big battery. In case of gasoline car, the energy transfer is more complicated. First, you have to use your battery to power starter. Starter further will start the engine, and only a few minutes later you will start to receive heat, in fact waste heat, from the engine to the cabin. And let's compare how it works in numbers. Let's consider, for example, 60 kilowatt-hour battery electric vehicle. I guess it's quite normal in modern days, keeping in mind, for example, Tesla or Chevy Bolt or some other modern vehicles. And let's even consider the case when I was rather stupid and forgot to charge my car and stuck on the road with low battery. For example, only 10% of battery, or 6 kilowatt-hour. 6 kilowatt-hour will allow me to boil electric kettle for 6 straight hours. See, example in electric kettle, because I drink green tea but not coffee, so it's harder to me to measure such energy consumption in coffee machines. So let's continue. 6 straight hours of boiling electric kettle. If we consider less consuming devices, for example, seat heating. Seat heating requires only 50 watt-hours. Watt, not kilowatt-hours. It means dozens of hours of seat heating for almost discharge battery of electric vehicle. And the next advantage of electric vehicle is that you can choose the source of heat. For example, if you don't have electric kettle in your car, or if seat heating is broken, you can use air conditioning. Of course, air conditioning, in fact, is a kind of weak point of modern electric vehicle, because air conditioning consumes 3 or 4 or even 5 kilowatts of energy. It's a huge amount. It's about 3 to 5 boiling kettles. To my understanding, it's just the problem that in the usual gasoline car you can afford not care much about the energy consumption for air conditioning, because you have a lot of wasted energy, a lot of energy which is generated via generator and stored in battery, and the battery is fully charged, it's just lost. So in the usual car you can afford yourself and not think about efficiency, but in electric vehicles it's much more important. And I hope that soon some producers of some engineer will try to earn some money developing heating and cooling system for transportation, for cars, for buses, and earn some money in fast-growing market of electric vehicles and electric buses. So in electric vehicle you have at least, for example, 3 different sources of heat: seat heating, air conditioning, and some extra devices which can be plugged into your outlet. In case of a gasoline car, what's happened? First, as I have said, you use your battery, and in fact this battery is smaller and often far not modern. For example, major part of conventional gasoline car use lead-acid battery. You can remember then even 1 century ago, some electric vehicle producer had a kind of option of lead-acid battery displacing, but more advanced nickel-iron batteries invented by Thomas Edison. So lead-acid battery is not so perfect, and usually when people talking that electric vehicles are not so suitable for winter, then keep in mind usual lead-acid battery, and we'll discuss the difference between lead-acid batteries and lithium-ion batteries later. So come back to the gasoline car. In gasoline car, you use your starter battery. A starter battery powers starter. Starter starts to rotate your engine, and engine starts to work. And a few minutes later, it starts to produce heat, waste heat. And the big problem of gasoline car during the winter is the very inefficient heat transfer from engine to the cabin. In fact, the gasoline car is usually designed to prevent this heat transfer, because you see usually this heating is not so good. It's good only during winter. So you utilize only 1 or few or maybe even less than 1% of all produced heat. So you heat not cabin, not yourself, you heat environment. So if we talk about gasoline car and electric car during the winter, electric car can provide you, for example, hours and tens hours of heating, but the gasoline car for the same condition can provide you less time of heating. And what is also very important, you see, using gasoline car is more risky, because you have to keep your battery okay, you have to keep your starter okay, you have to keep your engine okay, and only if all parts are working properly, you can have the heat. In case of electric vehicle, you have to control your battery, and if your battery is okay, even if it has about 10% of stored energy, it can still heat you for a very long period of time. So I hope that now you don't think that electric vehicles are not so suitable for cold weather.